All right, so up to this point, we've seen the limit comparison test in action and one example, and now I have two other ones here. On this first one, there's actually a typo. There should be a +1 in the denominator. Otherwise, it's not a very useful example. Okay, so I'm going to do this test right here. I'm going to do this problem and leave it to you to work on this one on your own. And you can see that this series, my hunch is that it converges, but I might not be right because the denominator is going to be larger than the numerator. So that's a hunch because sometimes the denominator is larger and it still diverges. So we should compare this to this series. N equals 1 to infinity of the square root of n over n squared. So, because what we're really saying is, well, this +1 here in the long run is not going to matter, this little constant. The root n and the n squared here is what's going to be driving the terms. It's what's going to make the terms big or small or grow at a fast rate or grow at a slow rate. So we can compare this, and let's use the limit comparison test. So take the limit as n approaches infinity. Let's see, of square root of n squared plus 1 divided by this term, so multiply by the reciprocal. Okay. So do some simplification here. This is the limit as n approaches infinity. On the top I have n squared and another half n, so that's n to the 5/2. In the denominator I have n to the 5/2, just distributed here, plus the square plus n to the 1/2. Okay. And you can use the leading terms and you can see that this will approach 1. So the limit comparison test applies in this case because the limit between the ratio of the terms are both finite and positive. It's +1 in this case. All right. So that means either both of these series will converge or both of them will diverge, and this one is easier to compare. So if we look at this series, that's n to the 1/2 on the top and n to the 2nd power on the bottom. So what you really have is n to the 3/2. Okay? And this again is a p series. Okay? So this is a p series with p equal to 3/2, which is greater than 1. Therefore, this will converge. Okay? And since this series converges, the other series that we were looking for will also converge. So both of them are convergent. Okay? So the limit comparison test again just goes to show, that if two series are very similar, they're off by a constant, and you can determine whether they're quote unquote similar by using this limit. Look, take the limit of each of their ratio of their terms, and if one of them, if the limit happens to be a positive and finite number, then they're basically going to have the same behavior. Okay. So there you have it. The limit comparison test and an example. I leave it to you to work on this example on your own. We will talk about it in class. Thank you for watching and have a wonderful day.